In this video, we will talk about probability spaces. And probability spaces are built from three different factors. The first factor is omega. Omega is essentially the sample space. What are the possible outcomes? The second factor is F sigma, which is a set of events or a subset of the sample space. And of course, the third factor is called P, or the probability. So basically, our question is the following. Given a certain sample space omega, what is the probability P of an event F? I must say that the subject of probability owes a lot to this mathematician, Gerolamo Cardano. Gerolamo Cardano, a 16th century mathematician, that his work on probability stemmed from the fact that he was also a gambler, so he noticed that the sample space is changing between games. Let us consider a flipping coin example, where I can get a tail or a head. So the sample space omega is equal to head or tail. That's my whole sample space. In other words, this is all the possible outcomes. When I flip a coin once, the outcome may be head or tail. But, and this is important, when I flip two coins, suddenly the sample space changes to something completely different. It can be either head-head, head-tail, tail-head, or tail-tail. The sample space size of a single coin flip is 2, while the sample space size of a double coin flip is 4. And if we flip 4 coins, the sample space size will be 2 to the power of 4, or 16. For those who are familiar with binary bases, we can assign 1 to tail and 0 to head, and the amount of different combinations between 0, 0, 0, 0 and 1, 1, 1, 1 is 16. Let's move to the concept of probability. How do I compute the probability of event A, or P of A? I need to do the following thing. Essentially, I'm taking the number of times that A occurs, and I divide it by the total number of events, or the sample space size. And therefore, we can write it as the number of A occurrences divided by number of omega, divided by the whole sample space. Let's give a concrete example. Let's assume that I roll a fair dice. What does the sample space look like? Omega equals 1, 2, 3, 4, 5, and 6. And let's define an event A as we got an even number on the dice. How do I calculate P of A? P of A should be the following, the number of times that A occurs, and in our example, this is 2, 4, and 6, which is 3 times, divided by the number of all incidents, which is 1, 2, 3, 4, 5, and 6. 6. 3 divided by 6, which equals half. So the probability that we get an even number in a single roll is 1/2. Same thing, let's assume that event B is to get a 7 in a single roll. So P of B equals 0. Why? Because the number of times that B occurs equals 0. Why? Because 7 never gets rolled. Just remember that P of sigma equals 1. This is the assumption of unit measure, that the probability that at least one of the events in the entire sample space will occur is 1. In the dice example, the probability to get either 1 or 2 or 3 or 4 or 5 or 6 in a dice equals 1, because something must happen. This concept of probability called frequentism, and frequentism means when I repeat the experiment many times frequently, the probability of event A will be the limit of the number of A occurs divided by n, when n reaches infinity. I want to finish this video with a great riddle. There is a famous paradox that's related to sample spaces that was invented in 1959 by Martin Gardner, and it goes like so. Mr. Smith has 2 children. At least one of them is a boy. What is the probability that both children are boys? Now, many people confuse and say 1/2 because we know that one is already a boy, so the probability to get in the other child a boy is 1/2 and a girl is 1/2. But this is not correct. Why? Because the sample space is different. The sample space when we have 2 children is either BG, boy-girl, GB, girl and boy, BB, boy and boy, and GG, girl and girl. In our example, we eliminate Gigi because we know that at least one of them is a boy. Therefore, we reduce the sample space from 4 to 3. And what is the probability that both children are boys means BB. So A occurs only once, while the sample space size is 3. Therefore, we get 1 divided by 3, or 1/3. And please try this riddle in your next party or social gathering and see what other people think about it.